So while I was busy procrastinating, I stumbled upon the site of artist Kumi Yamashita and her amazing artworks using this light and shadow technique, as for example this one or this one here. And while I by no means claim to have her mastery of the subject and the setting in which she does these installations, I was intrigued by the underlying technique. So let's start out building something like this here, and in order to have something that I want to project a shadow off, I downloaded this file here from Wikipedia, which is a paper cutout of artist Bernard Albert Moll's mother. As this technique works only somewhat successful on overhangs, such as in these areas or in these areas here, I further truncated the image to just show the main features of that face here. And when you're rebuilding the setup, you can experiment how much overhang and how much concavity the setup can cope with when you're feeding it your own images. The only thing that's important is that I have a black and white image here, having enough contrast to be able to trace it. So in Houdini, as always, I'm going to drop down a geo node, dive in there, and drop down a trace node, which allows me to trace a given image. I just need to load that image that we want to trace. In this case, I want to point it to this image that I prepared. Let's just scroll down here and uncheck show sequences as one entry. And here we have it, that cropped JPEG that I prepared. So let's hit accept. And you can already see something happening, something that does not look correct yet. So let's fix that by going to the filters here and check remove borders. So now we're only left with a poly outline of this cutout of a human face. Next, I'm just going to drop down the match size node to scale this to fit into a 1x1x1 box. And I want to make sure, in order to avoid these distortions here, to check uniform scale. And I also translated this to be centered at my world's origin 0, 0, 0. Now, when we're looking at these artworks here, clearly these shadows are projected from a point light source, or a light source that could be approximated with a point light. As with most of my recent free tutorials, I want to stick to rendering this in Octane. So let's open up the Octane tab here, and to this add a light. I just control clicking in here, then also control clicking on the camera to add a camera. And I want to make sure on the Octane light that also we're going to center it to our world's origin and have no rotation on it. And you can see that this light here is an area light. Octane takes physical accurateness very serious, sometimes, at least when it comes to light. And while it is true that in reality there is no such thing as a point light, because no physical object is infinitely small, I sometimes wish that Octane would allow for more freedom here. However, we're going to cope with this by going to the light tab here and setting the light type to be a sphere. And in the transform tab, just decrease the scale. So the light is very, very small along all of its axes, approximating a point light here. Also, what we clearly need is some wall or some geometry where we want to project this shadow here onto. So let's drop down a grid, dive in there and make sure it's aligned along the XY plane, like so, and go up again. And for now, I want to disable this grid because with the shading here, with the lighting, all of this is a bit messed up. Just for later, we keep in mind that we're going to need this grid. Now I want to move my Octane light a bit out of that plane where we want to project onto, maybe like so. So let's translate this 1.2 units in X and 0.2 units in the Z direction, and maybe move it up a bit as well. I don't know, 0.4. Like so. So what we want to create now is something that sits here at the end of this cutout, then casts this shadow here when hit with the light from this very small light source. So what we want to do is form a projection from this light source's single point towards this edge here of my cutout. To do so, I need my light source's position. So let's right click on here and copy the parameter and then go into our geo node here. And to project this outline onto our light source, the first thing I want to do is extrude this cutout here and give it a bit of depth. So I'm going to use the poly extrude, drop that down, increase the distance a good bit. Try not to get irritated by this weird display here. Maybe switch that over to wireframe. And then what I want to do is take all these points and collapse them onto a single point by going to the spine control tab here and then taking that second point of the thickness ramp and just dragging it down to 0. So all these extruded points here collapse onto one position. However, those are still a bunch of points here. So that's not a single point here, but close to 1500 points. Let's take all these points and put them into a group so we can move them around by using a group expression node. And we want to create a point group. Let's call this thing move. And in this group, we want to have everything whose position along the Z-axis is larger than a threshold, say 0.1. So now you can see we put all those points into this move group here, which we can now move around. And I'd like to move this group to our light source's position. Remember, we copied the position attribute from that Octane light source we created earlier. So let's apply to those points by using a point wrangle. And in here, I want to create a vector. Let's call this one npos for a new position. And I want to create a vector slider or a vector interface from which I'll read the vectors x, y, and z components. So let's call this one light underscore pause and create that interface. So now I've got this interface element down here. So let's right click on it and paste a relative reference, which will now link to my Octane light's position here. And now all I want to do is run this over the move point group that we specified here in the group expression. And we want to set every point's position that is in the move group to be exactly this end pause here by just going v at p equals to end pause, like so. And now we dragged over those points to our light's position. Now let's go back to our smooth wire shading maybe and just disable the lighting, the point and the point number display, and we can see what we created here. We just dragged out this shadow that we want to project onto our light source. And now what I can do is in here add some geometry somewhere in this area here and intersect it with what we just created in order to create a shape that will cast this shadow outline here when hit with a single light source from this point here. Let's, in this case, maybe go for a grid. Let's set this to be along the Y and Z plane. So in this direction, also maybe let's scale it down a bit, 2 by 2 units. And in this case, one thing that's bugging me is that this line where my shadow outline ends from the original image in the match size here does not sit on the 0 axis. So let's just go to the match size here and set the justify X to max. So now this line here sits at 0. Okay, back to our point triangle and as well our grid. So now I'll just give my grid a few more rows and columns before just wiring it into a Boolean where I intersect that grid with this weird extruded geometry I created. And in here, I want to set this Boolean to intersect, and I want to set my grid to be a surface and my second geometry here to be a solid. And as you can see, this does not yet work. We are getting some intersection in here, but it's clearly not what we expected because on the outside, this plane still exists. And for that to work properly, we have to make sure that in our poly extrude, this face here, the backside, is closed, which it currently isn't. So on my poly extrude, let's check output back and then go back to my Boolean here. And now we can see we cut out this thin strip from my grid and from that weird geometry that I fed in here. So let's take this, go up one level, re-enable that grid I put down there, and let's just drop down a few quick shaders by just closing these 3 tabs here, pinning that 1 tab, hitting Control T 3 times, and then hitting the Octane and Render target buttons, going to our out context where the Octane Render output sits for rendering out those images later, going to the ShopNet where our render target sits for configuring the rendering engine. In here I want to set it to path tracing, and that's all I want to do for now. Gonna switch my 3rd tab here to the materials, and I'm going to create 2 Octane material builders like so. Call one BG for background and one, I don't know, shadow maker, and going to the BG here, just dropping down a diffuse material for now, setting it to have a white color like so, and then wiring it up. And then in my shadow maker, again, same thing, want to drop down a diffuse material. In this case, I'll just set it to a dark gray value, wire it in here as well. So let's assign those on the OBJ level, the grid here that gets my BG material, and the geo, I'll assign shadow maker material to it. Let's switch our camera to the one we created here. Let's just have a look on its coordinates. And for now, I just want to center this and have it move back a bit and also kill all the rotation. So we're looking straight ahead. The light is here, and I think later we'll have to increase its power here. Let's just switch it to surface brightness right now. Let's save this and start our IPR. Not much to see yet, apart from a bit of what looks like AO and a white dot here. So let's go into our ShopNet here in the Octane Render target and set our environment to use a texture. By default, there is no texture loaded in, so we'll get a black environment. That's fine for us. And now I think we'll have to seriously increase this light's power here. Going back to our Octane light here into the shader black body emission tab, and then let's just increase this thing's power to, in this case, 500,000. And now you can see this light is absolutely blown out, but the shadow it casts results in this outline that we fed it. Let's go back to the shop and maybe add a bit of environment by using the texture environment tab here, setting the gamma to 1 and then loading up an HDR just by going here. For example, let's use this one. I think it comes from my exterior. And yeah, that gives this whole image a bit of an overall bluish tint. Maybe we need to decrease its power a bit so we get a bit more contrast in the shadows. And I think one thing that we can do is move our camera in a bit or move this light out of the camera frustum a bit so it doesn't overpower that whole scene here. Let's just go to the Octane light here and let's just move it over a bit. And you can already see my contour here gets a bit distorted. That is because Octane does not refresh the geometry. Let's just manually reload it. And you can see again, our setup already fixed the geometry. So the face outline is there again. Okay, maybe let's move our camera in a bit, or let's adjust its focal length, maybe to 85 millimeters, zooming in a bit like so. Now we can further increase our light's power. maybe to 1,000,000 or 2 for good measure. And that's the basis of this setup of how to generate a single surface that casts the shadow here. The surface does not have to be straight as in our grid, it could also be curved, or we could get a bit of inspiration from these kinds of images, where Kumi Yamashita built this shadowy outline out of objects here. And while clearly the art here is in selecting the objects and placing them so that their outline here where the shadow is cast, or rather here, is forming these very smooth areas of the lips and the nose, etc. I'm gonna go for a slightly bit more brute force approach, relying only on sticks of the same diameter that will allow us to form a shadowy image. To do that, we're gonna go back into our setup, diving into the geo where we build this Boolean grid here. What I wanna do now is scatter a bunch of points in this area here and instance on them a few sticks that have exactly the height from the position where the point is on this background grid here to the position at where it hits that weird geometry we created here, that orange geometry. And the idea behind it being, if I create enough single sticks, I will also block out enough light so that it shapes the exact same shadow here, but just making sure that each point which I generate on the background plane is going to be used to create a stick that is long enough until it hits the front side of this orange geometry here. A very naive idea of how to generate those points and their position on the background plane would just be to take this orange triangle, project it back onto our background, and then just randomly scatter points into this triangle. However, that would not be efficient, because what we want is we want to be able to form a blocker that shapes this shadow here with as few points as possible. And the most straightforward way I've found of creating such a point distribution that looks random while at the same time being spaced uniformly when projected along this y-axis here is with the following setup. I'll create a line. It already points up in the y direction. I'll just move it down 0.5 units because I know that my shadow generator here is just 1 unit in height, because previously I used the match size to scale my outline accordingly. So I'm going to take this line, give it a few more points, say 80, and this will dictate the number of sticks that will be in the setup finally and generate the shadow. And then to it attach an add sop. Make sure I check delete geometry but keep the points. So now in here I only have those 80 points from my line left. And then I'll just take this point triangle we wrote to move those points here to the light's position, copy and paste it down here and wire in my points here. And I want to change this code down here a bit. So I want to have it run over all points that are in this line group here. And I don't want to move all those points to this light's position here, but randomly between their original position and somewhat closer to the light. And also, I don't want the light to stick out of my background plane here. So let's fix that first, moving those points to the X and Y direction of the light only, but not to the Z direction, just going down here into the light position and just deleting that expression in the last slot here for the Z position, replacing it just with a default 0 like so, and maybe shift control clicking in here so the expression is not evaluated anymore. And now you can see when I enable point display that my points now sit at the X and Y position of the light, but have not been moved in Z direction, so they still sit on the background plane. Next, let's create a few sliders, 3 floats, call one min, call one max, and finally call one seed. So 3 float sliders, min, and then max, and finally seed. Let's create all these sliders, and for now, let's set min to 0, max to 1, and leave seed at 0 as well. So before I have this point triangle, my points are spread out evenly along this line. And after I move them, they are all at this point back here, where our original Octane light has been projected onto the background plane. And what I want to do now is I want to randomly, for each point, interpolate between this position here and its original position here. To do so, I want to use the linear interpolation function lerp, and I want to interpolate between the original point position and the new position that we created up here, the light's position, without the Z component. And I want to create a new value, which I'll call bias, to drive that. And if bias is 0, point's position is at its original position, and if bias is 1, it's at the new position. So to create this bias, I will take a random number from the point number plus the seed, and I want to fit this. And I know that this random number will be between 0 and 1, so I can use the fit 0, 1 function. And I want to fit it between our minimum and maximum value that we can use to dial in the offset. So now you can see that looks a bit more random, but down here the points are getting too squashed. So I will just decrease my max value here to say 0.6. And also if I wouldn't want those points being so close to my frontal line here, I could increase the minimum value as well. Now all I need to do is dial in the seed until it looks somewhat acceptable to my liking. Maybe let's start with something like this. And now we need to find out how high the sticks that we will copy onto these points should be. To find out, I want to take this geometry we created here. Let's switch the light over here. And I only want to keep these frontal areas and not the backside of this thing here. So I want to delete this. To do this procedurally, after this point triangle here, let's just move the Boolean and the grid to the side because we don't need it in this setup. So that's setup 1. Let's move it over here and let's bring in the line here. So after this geometry, I want to drop down a group node, uncheck base group, drag this down and enable keep by normals. The normal direction points along the z-axis, which is right because I only want to keep those normals, surface normals, pointing closely in that direction here. All I have to do is dial back the spread angle until we only have those front faces selected. If you want to be super sure about this, use an angle of 90 degrees. So now I can delete everything that's not in this group. So let's attach a blast node, check delete non-selected, and let's delete group 1, the one that we just created. So now we deleted all those back faces here. You can see before and after. Now I want to take this surface here and use it to generate scale values that sit on those points we just generated. And to do that, what I want to do is project from each of those points a ray along the z-axis and check where it hits this geometry here and calculate the distance from its original point. So let's drop down another point triangle. Points go in the first and my weirded out geometry goes into the second slot here. And I want to use the intersect function to send out rays from these points and check where they hit this weird geometry. Now the intersect function needs a few variables into which it stores the hit position, that's the position at which we are intersecting with this geometry, and the hit UV, so to store the UV coordinates at this position. Let's create these two vectors, call it hit P for hit position and hit UV for hit UV position, like so. Also, let's generate a vector that gives us the direction and the distance in which we want to look out where we're intersecting for this surface here. Let's call this one dir for direction, and let's set it to 0, 0, and say 10 units along the z-axis. So as my point light here is not dragged out very far, 10 units is plenty to find this geometry here. Next, I'll check where the intersections are using the intersect function, which will return the primitive number of the primitive it intersects with, or -1 if it didn't hit anything. So that's what we're going to store in this integer called hit. And we want to intersect the geometry coming in through our second input slot, ID 1. We want to send out a ray from our current point's position. We want to send the ray into the direction of our dir vector. And we want to store any resulting hit in our hit position and hit UV variables, like so. Now to get the length of the stick that we want to copy onto those points, let's create another variable, call it d for distance, and calculate the distance between our original point position from which we shot the rays and our hit position. That means at which position in space we intersected this collision geometry here. Finally, let's use this to create a scale vector, which we'll directly save on the point. So call this one scale and set it to something rather small along the x and y axis. Let's go with 0.01 for now, and we can adjust that later. And then d as our scale along the z-axis. Also, we need a normal to be able to instance those sticks later correctly. So let's create this manually as well and set it to be just pointing along the z direction like this. And finally, we want to make sure that if we didn't hit anything, we're just going to delete this respective point by checking if our hit primitive is smaller than 0. So if it's -1, then it didn't hit anything. And then we're going to just remove the current point we're working on, like so. Now let's finally copy sticks onto those points by taking a box, moving it out along the z-axis, 0.5 units, so it sits flush with the z-axis. Maybe, just maybe checking at vertex normals here, and then dropping down a copy to points, making sure I check pack and instance. Box goes into the left, points into the right slot. And now you can see I created boxes that exactly hit this weird collider geometry we created. Let's highlight this. Let's reframe our camera. Maybe do that on the object level here. Go to the transforms, make sure we are centered like this. And let's also get rid of the rotation. Save this, keep our fingers crossed, and go to the IPR. Now you can see I created this bunch of black boxes that exactly shape this outline of the shadow. And yes, some of those shadows are softer. That is due to the fact that our light source is not infinitely small. So if you want a sharper outline here, you'd have to make sure that those boxes would be closer to the actual outline we want to create. And we can do that by just going into the setup we just created. And on this point triangle here, we're creating those point positions. We can just decrease the max distance here and reload our renderer. And now you can see that this outline is a bit sharper, but you can also see that some of these boxes are too small. So there's some light leaking through it. And to fix that, we can go into this point triangle here and set this scale number here a bit higher. Let's just exchange that with a slider. So let's do a CHF, call it box scale. Now let's just copy this here and replace this fixed number with it as well. And then create that interface element. And now let's type a slightly larger number in here and reload this here. And now you can see there's no light leaking through. One more thing to break up this alignment a bit is rotate each box a slightly bit individually by in here between the point triangle and the copy to points, adding an attribute randomize, wiring this in here. I want to create an attribute called up for an up vector. Let's just close the IPR for now. And let's just set its distribution to direction or orientation. So now I just rotated those boxes randomly around their center a bit. Let's restart the IPR and let's look in a bit better. Let's just go to the Shadow Maker's material and maybe make this a little less dark so we can see a bit of the boxes, like so, a slight gray, or maybe even give those an orange tint, like so. And that is my take on generating those shadow outlines using what seems like a random bunch of geometry or objects, which in reality is something rather carefully and deliberately arranged in space. Let's just talk about the few tricks we did here. First, we generated this Boolean cutout, this clean cutout, by just taking our shadow target that we want, extruding it and moving its back points to the position of our light source here, and then intersecting it with a grid or any geometry that we want to cast shadow. And for our instant boxes down here, we were a bit more elaborate. First, we created a bunch of points that were spread apart evenly on a line, then made sure we kind of offset them to give them a random appearance in space, while at the same time just keeping inside this triangle that's formed when projecting the light back to our background. And then from each of those points, sending out a ray and sensing where the front side of this weird shadow projection geometry is, and creating a scale value to then instance and scale those sticks or boxes accordingly. Again, by no means do I claim to have the artistic vision of Kumi Yamashita, whose works you should definitely check out. At this point, I'm just being curious of what you guys create using this technique. So as always, if you have some artwork you want to share, please don't be shy sharing. We're always intrigued to see what you guys cook up. And if you maybe want to learn more about this vex that's going on here, or about rendering, about volume techniques, or even a bit of Unreal, or if you plainly want to support us, then you might want to check out our Patreon. And to everyone already supporting us, thanks so much. We always say this, but we mean it. Without you and Tagma in this form would not be possible. And a very special thank you goes out to Rodeo Effects, Important Looking Pirates, Sean Edwards, Chris Hebert, and Rafik Anadol. Thanks so much, guys. And as always, until next time, it is cheers and goodbye.